Here's a story about the evolution of mathematics, showcasing its significance, breakthroughs, and the brilliant minds behind it. The birth of mathematics, a universal language. Long before the written word, humans needed a way to quantify and understand their world. Early hunter-gatherers used simple tally marks on bones to count animals or track the moon's cycles. Mathematics began as a tool for survival, evolving into a universal language that transcends culture and time. The earliest records of mathematical thought appear in ancient Mesopotamia, Egypt, and India. Around 2000 BCE, the Babylonians developed a base, 60 system, which we still use to measure time, 60 seconds in a minute, and angles 360 degrees. Meanwhile, the Egyptians were using geometry to measure land boundaries and build monumental structures, like the pyramids. The Golden Age of Mathematics, Greece. By 600 BCE, mathematics began to flourish in ancient Greece. Thales of Miletus, often considered the first mathematician, used geometry to predict eclipses and measure the heights of pyramids using their shadows. Then came Pythagoras, who gave us the famous Pythagorean theorem, a cornerstone of geometry. His school of thought viewed numbers as the essence of all things, connecting math to music, philosophy, and the cosmos. Perhaps the most influential figure of this era was Euclid, whose book Elements organized geometry into a logical system that remained the standard for over 2,000 years. His work inspired later mathematicians and became a foundation of education in the Western world. Archimedes of Syracuse, another Greek genius, invented ingenious machines and laid the groundwork for calculus by calculating areas under curves and volumes of irregular shapes. Mathematics expands. India, China, and the Islamic Golden Age. While Greek mathematics was monumental, other civilizations made equally groundbreaking contributions. India, 500 to 1200 CE, Indian mathematicians like Aryabhata and Brahmagupta introduced concepts like zero as a number and negative numbers. The Indian numeral system, later adopted by the Islamic world and Europe, became the foundation of modern mathematics. Chinese scholars excelled in algebra, geometry, and number theory. They developed Pascal's triangle centuries before Pascal and used it to solve equations. Islamic Golden Age, 8th to 14th centuries, Muslim mathematicians like Al-Khwarizmi further developed algebra, a term derived from his book Al-Kitab al-Mukhtasar fi Hizb al-Jabr wal-Muqabala. His work introduced systematic solutions to quadratic equations. Omar Khayyam worked on cubic equations and geometry, while mathematicians like Ibn al-Haytham explored optics and mechanics. The Renaissance, a new era. The European Renaissance reignited interest in mathematics. Italian mathematician Fibonacci introduced the Hindu-Arabic numeral system to Europe through his book Liber Abaci and popularized the Fibonacci sequence. This period also saw the rise of giants like René Descartes, who combined algebra and geometry, creating the Cartesian coordinate system. His work laid the foundation for analytical geometry and modern physics. The Age of Discovery, Calculus and beyond. The 17th century saw the invention of calculus by two titans, Isaac Newton and Gottfried Wilhelm Leibniz, independently. Calculus became a critical tool for understanding motion, change, and the laws of the universe. Simultaneously, Pierre de Fermat and Blaise Pascal laid the groundwork for probability theory, while Leonhard Euler contributed to almost every field of mathematics, including graph theory and topology. The modern era, mathematics for all. The 19th and 20th centuries witnessed an explosion of mathematical ideas. 1. Non-Euclidean geometry * mathematicians like Gauss, Lobachevsky, and Riemann challenged Euclid's postulates, leading to geometries that describe curved spaces. 2. Abstract algebra and set theory * thinkers like Galois, Cantor, and Hilbert formalized the study of algebraic structures and infinite sets. 3. Applied mathematics * mathematics became a tool for understanding the physical world. Einstein's theory of relativity relied on Riemannian geometry, while quantum mechanics used complex numbers and linear algebra. 4. Computers and algorithms * the rise of computing in the mid-20th century, led by pioneers like Alan Turing, brought mathematics into the digital age. Algorithms and coding theory now underpin everything from internet security to artificial intelligence. Mathematics today, infinite possibilities. In the 21st century, mathematics drives innovation in fields like cryptography, machine learning, and climate modeling. It helps us understand the universe, from the smallest particles to the vast cosmos. Modern mathematicians explore unsolved problems like the Riemann hypothesis, while applications of math touch every aspect of our daily lives. Mathematics, born from the need to count and measure, has become the key to unlocking the mysteries of existence, a never-ending journey of discovery and wonder.